Hello everyone, welcome to your PDA. Today here we are at IIT Hyderabad in IInvenTiv 2024. So here we are with the Professor Somashekara from IIT Dharwad. So we are with a sir is with a very good innovative project. Just we want to hear from sir about this project. Sir, please explain us about this project.
So, as we know that about 3D printing, right? So far we have heard about 3D printing for last 20 years. So whatever the part that you print is basically in static nature,
Yes, sir.
right? So example, you talk about simple this part, right? Whatever the part that is printed, of course this is three-dimensional part. It always stay as a three-dimensional part, right? Even you try something like exposed to external stimuli, nothing will happen. But what we are actually trying to do is little bit one more dimension to it. Whatever the three-dimensional part, we are adding another dimension to it. So that is the dimension here is a time with time, but is what the time alone is not sufficient. So what happens here is over the time how the shape changes,
Okay.
right? Say like example, this is three-dimensional. So I want to actually unfold it,
Okay.
right? Unfold it, right? Or again fold it back.
Okay.
Right now this folding and unfolding, I'm actually programming it,
Okay.
right? I am programming such a that this will unfold and then
Unfold.
it will fold it. So now this part is already three-dimensional. Now I'm actually unfolding and then again folding it back.
Okay.
But what here I'm trying to do is I'm actually adding a new material, so that is called a smart material,
Okay.
right?
Smart material.
Smart material. Smart material, we also have two types of when it comes to metal and then when it comes to the polymer. So if we can classify broadly, right? So that is a shape memory alloys and then shape memory polymers. So in this, so what happens whenever you basically print, so you can actually infuse them, or it can be part of the 3D printing itself.
Okay.
Like example, if you see that polymer, right? What we do is we tune them, right? Their material or exactly the location where we need to actually infuse the smart material,
Okay.
right? So if you see this, like you imagine you have a compression, right? You compress it, imagine it will break it. So how to bring it back?
Okay. Reconstruction.
Reconstruction. It's like basically recovering the shape,
Shape. Okay.
right? So this time you are recovering the shape by just applying some external stimuli,
Okay.
and then you can reuse it. Like imagine you have the pellets,
Okay.
right? Imagine the pellet is almost about to break, right? And it's like almost like fractured, but it is not fractured, but it is almost like crumbled, right?
Okay.
So and then you put the external stimuli, and then you can actually bring it back. So this is a simple example that So another example, imagine you have that energy absorption, right? Like ballistic applications,
Sir.
right? It is almost like you are actually applying the load,
Okay.
right? It will almost like break it, and then how to bring it back,
Bring it back.
right? So that is when it comes to that polymer, right? Imagine you have the metal, right? You can see this part,
Sir.
right? So what happens that you want to pick something
Okay.
from the heating zone, right?
Okay.
So what is happening here is so these are the some of the printed part. So and then the shape memory alloys are actually infused,
Okay.
right, during the printing itself. So what happens is once you infuse it, so we actually understand what is the material point of view, at what temperature you can actually train, and then what temperature you can actually actuate,
Okay.
right? So once you understand, like imagine the simple physiotherapy, right, exoskeleton device.
Okay.
So typically you see that lot of motors and then actuator you will be
Yes.
using it.
Yes.
But what here is we are using a simple wires.
Okay.
So what we do is we supply a small current,
Okay.
right?
Input
And then you can actually take different intervals
Mm-hmm.
or different like example morning like you want to have a 10 times cycle, right?
Okay.
10 times you want to actuate it,
Okay.
and then afternoon you want to actuate another 10 times. So you can actually set alarm, like you don't remember, like at a different interval you want to actually actuate
Preset.
it, set. So what we are planning to come up with the new device, where actually you can run on a AAA battery or a AA battery,
Okay.
right? You supply small current. At morning you will have a 10 times physiotherapy,
Okay.
then afternoon 10
At
times.
home only. With
Yeah.
with
So
small
it's a small
equipment.
device.
Small
So
device.
where weight is very small. I mean less,
Okay.
right?
And it is
So you can
portable
actually
also.
set different intervals and then different times.
Okay.
So without patient intervention,
Uh-huh.
so you can actually do all that
Task.
physiotherapy,
Okay.
right? So it's something like you have the gripper mechanism, right? So you can see this different intervals,
Yes, sir.
right? You can actually pick the sample from. This is basically the hot, I mean this water,
Okay.
right?
Hot water.
Hot
Hot
water.
we are
So you can
picking.
actually once you immerse into the hot water, so actually this material will actuate,
Yes,
and then you can pick it,
sir.
right, and then leave. So what we understand basically here, what is the temperature of this material, at what time it will actuate, right, and then similarly we can also say different folding and unfolding of it.
Okay.
So yeah.
So what is the readiness of this project for
So
industry?
for we are presently at the TRL level 4.
Okay.
So this is the prototype of it. So you can see that the full view.
So what does it mean by TRL 4 means?
So this is basically laboratory level.
Laboratory level.
Yeah, so it has TRL and readiness level, right? What
Okay.
is the like prototype and different market level, right?
Okay.
So 7 means almost like you are into the
Ready for
ready for
industry.
market, right?
Okay.
So for we are now at the laboratory prototype, right?
Okay.
So you can see that you have the different units,
Yes, sir.
right? Like example, you have the printing area, and then you have the quenching area, and then you have the cooling and all, etc. So here you also have the robot, where actually robot will pick from different
Objects.
sections,
Objects.
and then it will infuse during the printing.
Okay. Sir, what are the key area applications of this project?
So for now, this is we have kept it a little bit open because our motive, I mean idea here is we want to develop the machine, I mean a technology point of view, 4D printing technology for different
For the printing technology it is.
Yes.
So with that anything can be printed.
Yes.
Okay.
So that is the whole idea. Like
Whole
example,
idea.
that's why you can see that we have exoskeleton, we have grippers,
Yes, yes. Lot
and
of
then we have
applications.
foldings, and then
Lot of applications I'm able to see here.
Yeah.
Actuators.
Right,
Okay,
right.
okay.
So
Skeleton
the idea
structure.
is at this point of time we have kept it little open
Overview.
based on the
Requirement
customer.
that
So that's why for now the machine is at the
TRL
laboratory scale.
Okay.
So based on the customer needs, and then we want to tune it accordingly, because we also have the polymer based, right? Example, we are thinking of developing some pellet,
Sir, okay.
right?
Sir,
Yeah.
one last question from my side. Sir, you are from IIT Dharwad. So, how are the research, I can say, research opportunities at IIT Dharwad and master's opportunities at IIT
We
Dharwad?
have plenty of opportunities, plenty
Okay.
of research positions are open.
Okay.
So I request you to watch out for our website, and then you can see a lot of area
This
research
kind
is
of
happening.
research. Okay.
Right? This is simple one group.
One group.
So we have like this 100 groups.
100 groups. Oh,
Right?
great,
So
great, sir.
I'm pretty sure you will be excited.
Definitely,
You
definitely,
can
sir.
come there.
Okay.
Yeah.
Thank you, sir. Thanks for explaining this wonderful project to
Thank
us.
you.
Thank you very much.